All right, let's jump into this DeepSeek-R1 thing,
Yeah,
an LLM that's really pushing the limits of what we think about reasoning.
it is.
We've got some fascinating research here from DeepSeek AI,
Absolutely.
and they've kind of gone all in on this idea of pure reinforcement learning,
Yeah,
which is pretty interesting because
Yeah.
they're ditching these massive data sets
right.
and going for more of a self-teaching model.
It's pretty amazing what they've done.
So for our listeners out there who really, follow LLMs,
Yes.
what are some of the things we're going to be unpacking today about DeepSeek-R1?
So first of all, we're going to be looking at how they developed their initial model, DeepSeek-R1
Okay.
and how they used pure reinforcement learning to get that model to be able to reason.
So that involved using the GRPO algorithm
Yes.
and kind of a unique reward system.
Yes.
So for those of us who are familiar with more traditional reinforcement learning, how does GRPO work?
Well, you can think of it this way. Instead of sort of comparing an output to like the perfect solution, GRPO compares it to other outputs that are generated in the same group.
Okay.
So you can imagine like a classroom of students who are all tackling a problem.
Right.
GRPO would rank those solutions, reward the top performers, and then nudge the other ones to adjust their strategies.
So it's a relative ranking system
Exactly.
that kind of fuels this whole learning process.
Yeah.
And I would imagine that this is beneficial for computational efficiency, right? Especially when we're dealing with these massive LLMs.
Right.
Traditional reinforcement learning can really get bogged down,
Yes.
calculating a value function for every possible state or action.
Absolutely.
And that gets really computationally expensive.
Very.
But with GRPO, they kind of sidestep that by focusing on relative performance
Yes.
within a group.
Yeah.
So I can already see why they chose that approach.
Yeah.
But how did they design the reward system to guide these outputs towards better reasoning?
Okay, so they did it in two ways.
Okay.
First of all, they created tasks that had very clear solutions,
Okay.
like math or logic problems, where there was a clear right or wrong answer.
Makes sense.
That way, they could measure how accurate the model's reasoning was.
Right, so it eliminates any ambiguity
Exactly.
in that feedback loop.
Yes.
But you said there was a second component to the reward system.
Yes.
What was that?
So, on top of accuracy, they also rewarded the model for presenting its reasoning in a very structured format.
Okay.
They wanted the model to show its work, basically,
Got it.
so that the reasoning process was transparent and human readable.
So it's not just about getting the right answer, but demonstrating how you got there.
Exactly.
So this must have been a big part of getting the model to be able to explain its reasoning.
Yes.
So essentially, this format-focused reward system incentivizes the model to think step by step,
Yes.
which is a very human-like way of reasoning.
Exactly.
Now, I know that during the training of DeepSeek-R1 there was this aha moment that DeepSeek AI documented what exactly happened.
So what happened was that the model started allocating more thinking time to the more complex problems.
Okay.
So essentially, it was pausing to kind of reconsider its initial approach.
So instead of just jumping straight to a solution,
Right.
it started taking a more strategic approach.
Yes.
Was that something that they programmed in?
No, this wasn't programmed in.
Wow.
This emerged naturally from the reinforcement learning process.
That's really interesting.
It shows the power of self-learning
Yeah.
to uncover capabilities that you may not have expected.
Now, for our listeners who are really interested in the technical details,
Yes.
can we dive a little deeper into the math behind GRPO and how that might have contributed to this?
Yeah, absolutely.
Yeah.
So at the heart of GRPO is this idea of maximizing what's called an objective function,
Right.
which basically guides the learning process.
Okay.
And unlike traditional RL, which often calculates what's called a value function, GRPO focuses on comparing outputs within a group.
Okay, so this objective function is sort of pushing the model towards using strategies that will lead to consistently higher advantages
Yeah.
compared to other models in its group.
Yes.
Now, how is this advantage actually defined mathematically within GRPO?
So the advantage is calculated by taking the difference between an output's reward and the mean reward of its group,
Okay.
and then normalizing that difference by the standard deviation of the group's reward.
So this normalization ensures that the advantage is kind of a standardized measure.
Exactly.
So you can compare it across various problem sets and outputs.
Yeah.
But there must be more to this objective function than just the advantage, right?
Yeah, there are a few other key parameters that fine-tune the learning process.
Okay.
One of those is a clipping parameter called epsilon,
Okay.
which limits how much the model's strategy can change.
So it's a safety net.
Yes.
Preventing the model from going off the rails,
Yeah.
these big shifts.
Yeah.
Do you think this relates at all to that aha moment?
It might. It's possible that by preventing these drastic changes, epsilon encourages a more gradual evolution of the model's strategies.
Okay.
And that might have allowed the model to kind of explore more nuanced approaches to problem solving.
Okay.
Which could have led to that shift towards strategic thinking that we observe.
That's really interesting.
Yeah.
So by carefully tuning that epsilon parameter, DeepSeek-AI might have accidentally created this.
It's possible.
This emergent behavior.
Yeah.
It really highlights this kind of interesting interplay.
It does.
Between the math of the algorithm and the way that the model is able to learn and adapt in these unexpected ways.
Absolutely.
So this has been really insightful, but I'm sure our listeners want to hear more about DeepSeek-R1 itself.
Yes.
Which was this refined model that they built upon DeepSeek-R1
Exactly.
So how did they address the limitations of that initial model?
So one of the key things they did was they incorporated what's called a cold start phase, where they pre-trained the model on a small set of high-quality chain-of-thought examples.
So it's like giving the model a crash course in thinking before letting it loose to learn on its own.
Exactly.
What kind of chain-of-thought examples did they use?
They were very careful.
Okay.
They prioritized quality over quantity, and they focused on problems that had clear step-by-step reasoning processes.
Okay.
Like math equations, logic puzzles, things like that.
So basically, they showed the model what good reasoning looks like.
Yes.
Almost like a teacher would.
Yes.
Guiding a student through a problem.
Exactly.
And this must have been really key for DeepSeek-R1's ability to articulate its reasoning process.
Absolutely.
It's this hybrid approach that makes DeepSeek-R1 unique.
Yeah.
Where they combined a small amount of supervised learning with that power of pure reinforcement learning. So this is all really exciting, but we've covered a lot of ground already.
We have.
Let's take a break, and we'll pick it back up in the next part, where we'll really dive into those specifics of DeepSeek-R1's training pipeline and all the amazing things that it achieved.
Looking forward to it. And what's really interesting is that this cold start phase with a little bit of supervised learning doesn't overshadow the real focus on pure reinforcement learning.
Yeah, it's more like setting the stage right. For that autonomous learning.
Yeah.
Rather than just, telling it exactly how to solve problems.
Exactly.
So after the cold start, what's next?
So then they move into a stage of what they call reasoning-oriented reinforcement learning.
Okay.
And this is specifically designed to make the model better at tasks with clear solutions. Things like math problems or logic puzzles.
So they bring back that GRPO algorithm and the reward system.
Exact.
But now with this focus on problems where you can really objectively measure whether the reasoning is correct.
Exactly. But they ran into an interesting challenge during this phase.
Oh, what was that? Did the model start, breaking the laws of logic?
Not quite.
Okay.
What they noticed was that the model had this tendency to mix languages.
Interesting.
Especially when they gave it prompts that weren't just in English or Chinese.
Okay.
It seems like the model, with its access to this huge multilingual knowledge base, had a little trouble keeping its languages straight.
So it's like having a really brilliant multilingual speaker who just jumps between languages mid-sentence.
Exactly.
So how do they fix that? Do they restrict its access to certain languages?
No, instead of limiting the model,
Okay.
they actually built a language consistency reward into the whole reinforcement learning process.
Oh, very clever.
So basically they rewarded the model for sticking to one language.
Right.
Throughout the reasoning process.
So they basically incentivized it to be more disciplined about its language use.
Yeah.
Did this affect its overall reasoning performance at all?
There was a very slight trade-off.
Okay.
So focusing on language consistency did lead to a tiny decrease in the model's accuracy on some of the reasoning benchmarks.
Okay.
But they decided that it was worth it.
Makes sense.
Because they wanted to prioritize readability and user experience.
Right, because a model that can solve all these complex problems but can't really explain its solutions.
Right.
Isn't that useful?
Exactly.
So it's all about clear communication.
Yes.
Especially when you're dealing with these really intricate reasoning processes.
Absolutely.
So after this stage of reinforcement learning, where they really focused on the reasoning,
yeah,
what was next in the pipeline?
Okay, so next they use a really cool technique called rejection sampling.
Rejection sampling.
Yeah, it's basically a way to generate more training data
Okay.
that specifically targets the model's weaknesses.
I'm intrigued. Tell me more about how that works.
So basically, they let the model loose on a new set of reasoning problems. But they didn't just accept any solution that the model came up with.
Right.
They had certain criteria for filtering out outputs that were either incorrect, poorly formatted, or just not good enough.
So they're being really selective here.
Yes.
And using those top-tier solutions
yeah.
to further train the model.
Exactly.
What were some of those criteria that they used to filter those outputs?
Well, for tasks with clear answers, like math problems, they could just automatically check if the answer was correct.
Right.
But for more open-ended tasks, they actually had human annotators assess the quality of the reasoning.
Okay.
That way they can make sure that the new data set was really high quality.
So it's like having this panel of expert judges.
Yes.
Evaluating the model's reasoning.
Yeah.
And only selecting the best.
This is so clever.
Yeah.
They're using the model's own strengths and weaknesses to create this custom training set.
Exactly.
Really smart.
But the very efficient way to keep improving the model.
Yeah.
So after this rejection sampling stage,
yes.
did they keep going with this very targeted reasoning focus?
Actually, they broadened the scope a bit.
Okay.
At this point, they started incorporating data from lots of different domains beyond just reasoning.
So they're exposing it to a wider range of tasks.
Right.
Like writing, question answering.
Exactly.
Maybe even some self-cognition type of stuff.
Yes, exactly.
So they're trying to make it a more well-rounded, versatile LLM that can handle all sorts of challenges.
Exactly.
But they didn't stop there, right?
No, they went back to reinforcement learning for one final stage.
So we're back to GRPO and that reward system
yes.
for this grand finale.
Yeah.
So what's the focus of this final stage?
Alignment. Making sure that the model's outputs are not only accurate, but also helpful and harmless from a human perspective.
So they're not just focused on the model's intelligence, but also its ethical implications.
Yeah.
And how it interacts with it. That's really important.
They use a mix of reward signals and different kinds of prompts to guide the model's behavior. For the reasoning tasks, they stuck with those rule-based rewards we talked about. But for more general tasks, they started using what are called reward models.
And these reward models have been trained on human feedback, right?
Exactly.
So they can judge how good an output is based on what we humans find helpful and safe.
Yeah.
It's this really important human-in-the-loop aspect.
It is.
To make sure that these models are aligned with our values.
Absolutely.
And our expectations.
Yeah.
So this whole focus on alignment is really a testament to DeepSeek AI's commitment.
It is.
To developing AI that is not only powerful, but also responsible and beneficial to society.
I agree.
So we've journeyed through this whole training pipeline. From the cold start all the way to this final alignment phase.
It's pretty impressive.
It really is. It's a very sophisticated and well thought out approach.
Yeah.
But there's one more piece of the puzzle, right?
Right.
And that is knowledge distillation.
Yes.
So they experimented with taking all this reasoning power of DeepSeek-R1 and distilling it down into these smaller, more efficient models.
Exactly.
Let's talk about that in the last part of this deep dive.
Okay. We can also discuss some of the limitations of the model.
Okay.
And what it all means for the future of LLMs.
Yeah, I'm looking forward to that.
Yeah.
So we've really gone deep into this training pipeline behind DeepSeek-R1.
We have.
A model that's really changing what we thought was possible. When it comes to reasoning in LLMs.
It really is.
But before we wrap up, I'm really curious about those experiments with knowledge distillation.
Yes.
What did they do and why?
So basically, they wanted to see if they could take all that reasoning power of this massive model and transfer it into smaller, more efficient models.
I see. So it's like democratizing access to this really advanced reasoning capability.
Exactly.
How did they actually go about doing that?
They used a technique called knowledge distillation.
Okay.
So instead of training the smaller models from scratch on all that original data, they trained them on the outputs that DeepSeek-R1 had generated.
So the smaller models are learning not just from the final answers,
Right.
but from the entire reasoning process.
Exactly.
The steps along the way.
Yeah.
Kind of like having a personal tutor.
Yes.
Who's already mastered the subject.
Exactly.
And can walk you through it.
Yeah.
What were the results?
The results were really impressive.
Okay.
So obviously these smaller models didn't have the same raw computational power as DeepSeek-R1.
Right.
But they still showed really impressive reasoning abilities.
Okay.
In fact, they even outperformed some larger models on certain benchmarks.
Wow. So that suggests that the essence of DeepSeek-R1's reasoning capabilities can be transferred to these smaller models.
It can.
That's huge.
It is.
For accessibility in research.
Absolutely.
It means that people with limited resources can still experiment with this cutting-edge technology.
Exactly.
Now, DeepSeek-R1 is amazing, but it's not perfect.
Right.
DeepSeek AI was really upfront about that.
They were.
What were some of those limitations?
One of the things they mentioned was that they need to enhance general capabilities beyond reasoning.
Okay.
So DeepSeek-R1 is amazing at things like math and logic,
Uh-huh.
but it still struggles with things like function calling, multi-turn dialogue, and those really complex role-playing scenarios.
It's kind of like this specialized expert who needs a little help navigating the broader world of language and interaction.
That's a good way to put it.
Were there any other limitations that they mentioned?
They also acknowledge that they're still working on that language mixing issue.
Right.
Especially with prompts that aren't in English or Chinese.
Even with that language consistency reward, it still needs some work.
It does.
They're trying to make it a truly global language model.
Exactly.
Fluent and accurate across a ton of different languages.
Yes.
It's been incredible.
It has.
Talking about DeepSeek-R1.
Yeah.
This model that's really changing the game.
It is.
When it comes to reasoning and LLMs.
For sure.
What are some of the key takeaways our listeners should remember?
I think the biggest one is that you don't necessarily need massive labeled data sets. To achieve advanced reasoning.
Yeah. DeepSeek-R1 proved that.
It did.
Just with pure reinforcement learning.
Yeah.
A well-designed reward system.
Exactly.
Amazing results.
It's really a testament to the power of these algorithms.
Right, GRPO.
Yeah.
To unlock these incredible learning capabilities.
Absolutely.
And beyond just accuracy, DeepSeek AI really focused on readability.
They did.
Human alignment.
Yes.
And that knowledge distillation.
Important factors.
So they're not just building intelligent LLMs, but LLMs that are understandable, ethical, accessible.
Absolutely.
They're setting a new standard for the field.
I think so.
It's been fascinating.
It has.
Learning about all the intricacies of DeepSeek-R1.
Yeah.
And I want to leave our listeners with this thought.
Okay.
Imagine a future where these incredible reasoning capabilities are available to everyone.
That would be amazing.
Empowering us to solve those really complex problems.
Yeah.
Make better decisions.
It's an exciting future.
And unlock possibilities we haven't even thought of yet.
Absolutely.
That's the future that DeepSeek-R1 is pointing to.
It is.
And it's a future I'm really excited to see.
Me too.